So in this video, I'm going to be going over the Chapter 4 review. Number 1 wants me to evaluate f of x equals e to the 2x for x equals 3.2, and then round to the nearest thousandth. So the first thing I'm going to do is I'm going to plug in this value. And then I'm going to go ahead and type this into my calculator. So I go second ln, and then I type this in. If I'm on an older calculator, I might want to make sure my parenthesis or my exponent is in parentheses, because the calculator will read the first number as your exponent and then multiply the entire answer by that second number. So this gets me 601, and then it wants me to round to the nearest thousandth, which is 3 decimal places. So 601, I probably don't want that off the screen, 0.854. Number 2 wants me to say how much money I will have in a bank account if I invest $3,500 for 5 years in an account that earns 3.4% compounded quarterly. So remember, this is the formula, A equals P times 1 plus R over N raised to the NT power. P is principal, how much I start off with, so the 3,500. R is interest rate as a decimal, so I can divide by 100 to turn this into a decimal, which is 0.034. And that's my R. N is number of times compounded in a year, so how many quarters there are in a year. There's 4. And then my T is time, so 5. So then I just want to plug into this equation. I'm going to have 3,500 times 1 plus 0.034 divided by 4 raised to the 4 times 5. So then I can go ahead and type this into my calculator. Okay, so since I'm dealing with money here, I want to round to 2 decimal places. This is going to be 4,145.59 cents. I round up because that number after the 8 is a 7. Okay. Number 3 wants me to evaluate log base 4 x for x equals 15. So then I'm just going to plug in 15. And then I can type this into my calculator. If I am using a newer one, like the one I have right here, I can just go math, arrow down to choice A, which is log base, press enter. Then I put in the 4, arrow over, type in 15, and press enter. This one again wants me to round to the nearest thousandth, so 1.953. If I am on an older calculator, what I can do here is I can do log my argument, so the 15, divided by log my base, which is 4, and then press enter, and it gives me the same answer. Okay. Number 4 again wants me to evaluate this logarithm. It's again in a log base, so I'm just going to go math, arrow down to log base, type in 14, and then what was the other number? 275. Again, it wants me to round to the nearest thousandth, so this is going to be 2.128. Number 5 wants me to expand the logarithm, so break it up into parts. Multiplication on the top gets split up with addition. Numbers being divided get split up with subtraction. So I'm going to have log base 4, and then I'm going to have 3, and then I'm going to do log base 4 x squared, because that's on the top. Then I'm going to subtract log base 4, 2, because the 2 was on the bottom. And then subtract log base 4y. Then I need to make sure I don't have any exponents. I do have an exponent, so the exponent's going to move out front. This is going to give me log base 4 of 3 plus 2 log base 4 of x minus log base 4 of 2 minus log base 4 of y for my final answer. 6 is going the opposite direction and wants me to condense into one logarithm. So I want to start off by putting my exponents back where they belong. So those two are going to move. Whenever I move the exponents, I move the number and I don't include the sign. So I have ln 5 plus ln x squared. Ooh, and I missed an exponent. That one's going to go there as well. So this negative sign is going to stay. And then I have ln y cubed minus ln z to the 1/2. I can remember that 1/2 is square root. So I'm going to rewrite that one. Then I can go ahead and put this back together. Like I said, addition turns into multiplication. So I'm going to have ln 5x squared, and then divided by, oops, that's y cubed, and then square root of z. Because both of those go on the bottom because they both have subtraction. So this is my final answer. Number 7 wants me to solve this equation and round to the nearest thousandth. So I'm going to divide both sides by 2. This gives me e to the 4x equals 36. Then I can use my logarithmic properties to rewrite this. Because it's base e, I'm going to have ln. And then my exponent and answer switch places. So I'm going to have ln 36 equals 4x. I want to isolate my variable. So I'm going to divide both sides by 4. And this gets me ln 36 divided by 4. And this is what I want to type into my calculator. I'm going to do ln 36, close the parentheses, and then divide by 4. This is because ln 36 is a different number that is not 36. So this gets me 0.896. Okay. Number 8, same idea. I want to solve and round to the nearest thousandth. So I'm going to start off by subtracting 4 on both sides. I get 3 times 2 to the x equals 15. I want to go ahead and divide both sides by 3. I get 2 to the x equals 5. I can rewrite this as a logarithm. It's going to be log base 2. Then my exponent and answer switch places. So it's going to be 5 equals x. Then I can just type this into the calculator. I'm going to go to math, log base, type in 2, type in 5. This is going to give me 2.322. Okay, number 9 wants me to solve this logarithm. They both have, or this equation, they both have the same log base, and there's one log on each side and nothing else. So for these two, I can actually take their insides and set them equal. So I'm going to have 3x minus 7 equals 6x minus 19. Then I want to start off by subtracting 3x on both sides. This gets me negative 7 equals 3x. And then I have negative 19. I want to go ahead and add 19 to both sides. 19. That gets me 12 equals 3x. I can go ahead and divide both sides by 3. And I get x equals 4. Okay. Number 10, I have 2 logarithms on the same side, so I want to go ahead and condense them. Remember, addition means multiply the insides. Subtraction means subtract the insides. Divide the insides. So I'm going to write ln, and then I'm going to multiply them. I'm going to have 3 times x minus 8 equals 5. So I'm going to go ahead and distribute that inside. So I have ln 3x minus 24 equals 5. Because I have a logarithm equaling a number, what I want to do here is rewrite it as an exponential. ln means base e. And then it's going to equal my argument, so 3x minus 24. I want to go ahead and add 24 to both sides. I get e to the 5th plus 24 equals 3x. I want to isolate my variable, so I'm going to divide both sides by 3. So I get x equals e to the 5th plus 24 divided by 3. When I go to type this in the calculator, I want to make sure my numerator is in parentheses, because otherwise it will just divide the 24 by 3 and not the e to the 5th. So I'm going to type this in. I have e to, oops, I did not start off with my parentheses. I'm going to go e to the 5th plus 24, close my parentheses, and divide by 3. This gets me 57.471.